The lesson today is over dividing exponents. Last time we did multiplying exponents, and just like last time, we're going to start out by looking at an expression and being asked to simplify it. So if I have something with division, it's got the fraction line, like a to the fifth over a squared, I want to think about, well, what is this saying? So if I wrote it out longhand, basically on top of the fraction, a to the fifth is a times itself 5 times. And a squared on the bottom is a times itself twice. So that's really what I'm looking at here if I wrote it out longhand. Now think about what this would reduce to. Well, hopefully you know that if you have the same thing on top and bottom, you can just cross off one of those pairs. So I can cross off 2 pairs of a's, and that would leave me left with just, there's nothing on bottom anymore, so it's not even a fraction anymore. I just have a times a times a, which I could rewrite as a to the third. So if you look at what I started with and what I ended with, a lot of you would notice that, oh, well, if you just do 5 minus 2 and subtract the exponents, that's your new answer. And that's exactly what the shortcut is. With multiplying, we added the exponents to bring them together, and with dividing, you're going to subtract. So if I wrote out like a general rule with letters, notice that the bases have to be the same. So they both have to be a terms or h's or c's. This only works if the bases are the same. But if you've got division, you can bring the a's together by just subtracting the 2 exponents. It's always top minus bottom. So in the general form, this would be m minus n. That would be your new exponent. So you just subtract. Now, well, seems pretty straightforward, but if you want to know where people start messing up, it's when they throw negatives in. That's when people start making mistakes. So if I tried this one, h to the negative 3 over h to the 12, I could use my shortcut here, and I could bring these h's together by just subtracting the top exponent minus the bottom one, and that would give me h to the negative 15, which of course I wouldn't leave it like this because that's not simplified. I would bring this down to the bottom and write 1 over h to the positive 15. Now, another way that you could have done this problem is you could have gone back to the beginning, and instead of using your division property, subtracting the exponents, you could have started by moving the negative exponent down to the bottom, and that would give you 1 over h to the 3, h to the 12, and then you'd use the multiplication property because you're multiplying those, and you would add the exponents. Either way, though, you would still get 15 h's on the bottom. So that's where I guess these can be just a little tricky because sometimes you can do things in a different order, which I guess that's nice, and still come up with the same answer. Now, I'm going to fill in the exact same steps that I did last time. This is going to help guide you if you're having trouble starting. Now, the first thing that you always want to do, and it's just like when you're solving an equation. Remember, if we're solving an equation, we always distribute first. So that's the first step here. If you can distribute the exponents, or in other words, remember when you have parentheses with a little exponent out like back there, you always want to start by distributing the exponent. When you do that, you multiply exponents together. Take care of the distributing first. Then you want to see if you can combine any like base terms. And I'll give you an example of what I mean. Say that I've got like x to the 5th times x to the 4th. Those are like base terms. The bases are both x. You want to bring those together for it to be simplified. In this case, you would add the exponents. Since it's multiplication, you're going to see a lot today of bringing together like bases using the division property, which is subtracting, what we just talked about. Okay, so you got to combine x's, y's, get like base terms together. From there, this should be step 3, last one should be step 4, same mistake as last time. It's not simplified if you have negative or 0 exponents, so you've got to take care of those. Okay, more reminders. Negative exponents, you take care of them by flipping them across the fraction line. So I'm just going to write flipped. And then remember that anything to the 0 power is going to equal 1. The last thing you want to take care of is you want to evaluate any numbers. And example of this, it's all the same as last time. If you've got 2 to the third sitting in your expression somewhere, you want to write 8. Or if you've got 3 squared, say 9. Okay, so figure out the number. You got to do that for it to be fully simplified. All right, just takes practice, so let's get into it. Number 1, I see division. I see like bases, C's. I have no distributing. So what I want to do is bring these C's together, and I'm going to do that by using the division property, what I just learned. So to do that, I subtract the exponents. So I'm going to write it out. I probably won't from now on. I can bring the C's together by doing 9 minus 15, which would give me C to the negative 6. I know that I can't leave it like that, so I combined, but I've got to take care of the negative exponents. And I want to bring this to the bottom. So my final answer is 1 over C to the positive 6. All right, on the next one. So here's where the steps can be like changed around if you want to. People will make the mistake, they'll do negative 3 minus negative 8, and you can do that. Be careful, use your calculator. You would do the top minus the bottom. So that's a lot of negatives going on. When you combine them, it is p to the 5th. If it's easier for you to not look at negatives, maybe you want to start by flip-flopping this thing. Do step 3 first and take care of the negative exponents. So I could rewrite this as p to the 8th over p to the 3rd. And then I could subtract 8 minus 3, and I could see real easily in that case that this would just be p to the 5th. You could start off with the division property and just subtract them right away. Just watch your negatives. Okay, I should also say that after you use the subtraction property here with division, you always write that answer on top. So like here, when I do 9 minus 15, negative 6, it's always on top. Okay, you're going to move it if you need to, if it's negative. And think back here to what you started with. If I go back to example 1, are there more C's on top or bottom? Well, there's definitely more on bottom. There's 15 on bottom. So my final answer, the C's need to show up on the bottom. Okay, so maybe think if your answer makes sense. We don't stop to do that often enough. All right, here's what I'm going to do on number 3. So again, I could just do negative 3 minus 6 and use the division property, or I could start by moving the negative 3 to the bottom. And then it would be positive 3 on bottom. You still need to bring the m's together. Right now, I'm going to be multiplying them, so I would need to add 6 plus 3, and that would be m to the 9th on bottom. If you see something like example 4, so there's not distributing on any of these. I don't have parentheses, but I can combine like base terms. So I need to put the C's together and the D's together. Do them one at a time. And they're both division, so I'm going to subtract exponents. That's C to the 1 on bottom if I don't write an exponent. So, okay, I know when I do my subtraction, I write the final answer on top. So 7 minus 1 is C to the 6th. And then 3 minus 8, that's d to the negative 5th. Always put it on top, even if it's negative. If it's negative, you just move it to the bottom to make it positive. So the best answer would be c to the 6th over d to the 5th. All right, on the back, these are tougher ones. Now, here's where you're going to have like a fraction raised to a power, or the parentheses are going to be involved. When you see this, you start with step 1 back here. You're going to distribute the exponent to every single term inside the parentheses. Everything is going to be raised to the 3rd power on this first one. Or number 4, everything inside the parentheses is going to be squared, even the stuff that's on the bottom. Okay, just follow the same steps and you should be okay. Be careful. Watch how I do number 1 here. So the 2 and the 3 need to be raised to the 3rd power. If it doesn't have an exponent, put 1 in. Okay, we saw this last time. The only difference is there's a fraction line now. But these guys have a 1 as an exponent. So when I distribute, I need to multiply. I multiply exponents when I distribute. Multiply 3 times the 1 here and the 1 on the bottom. Be careful, don't multiply the base, the 2 by 3, you multiply the exponents. So this would be 2 to the third over 3 to the third. I can't combine those because this base is a 2 and this base is a 3. So my last step is just to evaluate the numbers. 2 to the third is 8 and 3 to the third is 27. Okay, so that's kind of what I want to do to approach that one. I can't reduce that, so that's my answer. Okay, on number 2, same thing. So the 4 doesn't have an exponent, so I'm going to stick a 1 in there. And then I'm going to go ahead and distribute the 2, and I'm going to multiply all the exponents out. So this would be 4 squared over x to the 6th. There's no negative exponents, there's no 0 exponents. The only thing that can make this better is if I write 16 on top instead of 4 squared. All right, I want you guys to try number 3. I also want you to try number 8, so I'll just circle those 2 right now. Those are the 2 I want to see you trying. I'll check them next time. All right, number 4. The thing that people will do, number 1 mistake here, is they'll forget to give the 3 an exponent and the 2 an exponent. They'll forget to write 1s there. But make sure before you distribute, you put those 1s in so that way everything gets a 2. This is kind of a lot, so follow close. This would be 3 squared m to the 6th n to the negative 8, just multiplying the exponents. On bottom, this would be 2 squared p to the 12. All right, m's, n's, and p's, so I can't combine any base terms. So I just need to take care of negative exponents. So the n needs to move to the bottom. I also know that I can write 9 instead of 3 squared, and I can write 4 instead of 2 squared. So let me go ahead and do that right now. It'd be 9 m6 on top over 4 n8 p12. You could write P12 and 8, it doesn't matter. Just make sure you write the number first. It always looks nicer that way. I can't do anything else, so this is actually my final answer. All right, number 5. All of these guys, I'm distributing the exponent first. That's my first step if I can do it. So get your 1s in there. It's okay that it's a negative 2. We'll take care of that later. Distribute first. It would be 3 to the negative 2 over 4 to the negative 2. I obviously know that I cannot leave negative exponents, so I'm going to flip-flop this thing. So I'm going to put 4 squared on top, 3 squared on bottom, and then I'm going to go in and evaluate the numbers. So I'm going to write 16 over 9. That's the best answer. All right, number 6, and as you can tell, it's kind of all the same thing, it just takes some practice here. I gave each part, the 2, the r, the s, all a 1. Now I'm going to distribute. So it'd be 2 to the negative 1, r to the negative 1, s to the negative 1. Everything needs to move. Everything has a negative exponent. So my answer is going to be good from here. So it'd be s to the positive 1 over 2 to the positive 1, r to the positive 1. That's my answer. All right, number 7 here, same thing. It's kind of getting redundant, so sorry. This would be x to the positive 15, watch your signs, y to the negative 6 over z to the positive 12. And then I would need to move the y down to the bottom. So my final answer would be x to the 15th over y to the 6th, z to the 12th. All right, last one before I show you a scientific notation problem. Number 9, notice people, I guess, maybe would make the mistake of distributing the 3 to everything, but you only distribute the 3 to what's in parentheses. So give the 3 and the k their own exponent of a 1, and then multiply through on the bottom, so the top isn't going to change yet. I'm looking at something like that. On the bottom, it would be 3 to the third, k to the third, and p to the 9th. Okay, so I distributed. Now I can combine some stuff here. So I need to put the k's together, and I need to put the p's together. So I'll worry about the number later. You need to subtract the exponents to do this. So for the k's, it's 3 minus 3. So those are actually just going to eliminate, which is pretty easy. For the p's, subtract and do 2 minus 9, and that would give me, I don't know if you guys can hear that, but my little twins are like yelling in their beds. So sorry, I'm kind of laughing a little bit. On the bottom, 3 to the third is 27, so I'm going to rewrite that. And then p's here, 2 minus 9 is negative 7. You always write that on top after you do the subtraction property. Then I'll move it down to the bottom. So this would be 9 over 27 p to the 7. This one's kind of weird. You can actually keep reducing the number, so you should always kind of like analyze the fraction. It's 9 over 27. You can divide both of those numbers by 9. So if I did that, it'd be 1 over 3 p to the 7. That's the best answer. Okay, the last problem. Sorry. Scientific notation, I told you it would kind of like follow us throughout the unit. So here's how you would use the division property from today to do scientific notation. So basically, the first thing you want to do, if you're asked to divide two scientific notation numbers, these are both really big numbers because they're positive exponents. It's really similar to what we did with multiplying last time. You just divide the a values. So that's kind of like general form scientific notation. The a values are the first numbers. So that's the first thing I want to do. 7.5 divided by 2.5. So that's just 3. Then you're going to bring the tens together by subtracting the exponents. Here's kind of like where the property from today comes in. So I would do 4 minus 6, top minus bottom, and it would be negative 2. Easy as that.